Today on Radio Boat Anchor, I'm going to repair this vintage 1983 Radio Shack Micronta 21 reigns Volt-Ohm-Meter. The Radio Shack Micronta 21 reigns Volt-Ohm-Meter to the left looks very similar to the Simpson 260 to the right. I believe this is by design, with Radio Shack trying to cash in on the popularity of the Simpson 260's reputation for durability and accuracy. Unfortunately, the Radio Shack Micronta 21 reigns Volt-Ohm-Meter is more cheaply constructed than the Simpson 260, with an ABS plastic case and inexpensive meter movement. The Radio Shack Micronta 21 reigns Volt-Ohm-Meter, catalog number 22-210, first showed up on page 105 of the 1983 Radio Shack catalog. This Volt-Ohm-Meter was the most expensive analog offering in 1983. The advertisement for this meter boasted the following: fused and overload protected, big 5-inch color-coded scale, beep continuity function, easy access to the battery and fuse compartment. Repair. A common issue with the Radio Shack Micronta 21 reigns Volt-Ohm-Meter is that the meter does not properly deflect, even with the changing of the meter adjustment screw. Don't get too aggressive with turning this screw, as it connects to the delicate movement. In this video, I will attempt to correct the issue with the meter movement and any other issues that present themselves. Time to remove the back cover in order to inspect the electromechanical innards. First, the battery cover must be removed. It is held in place with one captive screw. The 9-volt and C battery must be removed before the back cover can be removed. I also removed the fuse and spare in order to make sure I didn't break them during back cover removal. 3 screws hold the back cover in place and must be removed. The electromechanicals look to be in pretty good shape, with very little signs of tarnish or corrosion. Although it looks like the ammeter shunt has been overheated by excessive current more than one time. I turned the meter over and set the dial to the off position. Then removed the wiper assembly that is held in place with one nut. 3 screws hold the printed circuit board in place. 2 had already been removed when this picture was taken. The fuse holder was then unscrewed from the back of the meter. I carefully lifted the printed circuit board to expose the wired connections to the inside of the front case. There is a switch that connects to the dial. Both contacts must be unscrewed from the inside of the front case. In addition, a screw must be removed from the piezoelectric speaker contact so that it can be removed. The meter and printed circuit board assembly can now be removed as a unit from the inside of the front case. I decided to disconnect the meter from the printed circuit board to make servicing it easier. First, I desoldered the meter connections. Then, on the back of the meter, the battery connections were desoldered. At this point, the meter was free and clear of the printed circuit board. When I removed the opaque plastic cover, I discovered a pivot adjustment screw. Unfortunately, no manipulation of the pivot adjustment screw would get this meter to properly deflect. I believe that the hairspring in the meter movement has sprung due to wear. The meter needed to be replaced. I found a suitable replacement meter that properly deflected on eBay. The replacement meter dial was faded due to sun exposure, and its clear faceplate had yellowed. The meter dial was held in place with 2 screws. I replaced the meter dial and clear plastic faceplate on the working meter from the broken one. Here is the replacement meter with newly installed meter dial and clear plastic faceplate. The replacement meter had brakes and an insulation on the wires. I covered the brakes and insulation with heat shrink tubing. Deoxit D5 contact cleaner was used to clean the contacts on the printed circuit board. It is amazing how this contact cleaner removed the tarnish. During contact cleaning, I discovered there was a break in the printed circuit board trace. I drilled a small hole in the trace, then soldered a jumper to the nearest component, a diode. Here is how it looks from the solder side. Contact cleaner was used on the wiper contacts as well. I sprayed Deoxit D5 contact cleaner into the opening of the ohms adjustment potentiometer, then worked it in by twisting the control from one end stop to the other several times. The same cleaning treatment was applied to the polarity switch. The Bell 107 plastic-friendly oil was applied to the base of the shaft on the ohms adjustment potentiometer, and to the base of the shaft of the polarity switch as well. During cleaning, the ammeter shunt broke. I resoldered the ammeter shunt connection in place using a high-powered solder iron. Reassembly. Time to reassemble the Radio Shack Micronta 21 reigns Volt-Ohm-Meter. First, the meter's connections were resoldered to the printed circuit board. Then the battery connections were resoldered in place. Meter and printed circuit board assembly were then ready for installation. The front cover was turned upside down in order to prepare it for meter and printed circuit board installation. Meter and printed circuit board were dropped in place. There is a switch that connects to the dial. Both contacts must be screwed to the inside of the front case. In addition, the piezoelectric speaker was installed and a screw that holds the contact. 4 screws were installed in order to hold the meter in place. Then the fuse holder was fastened down with 1 screw and the 9-volt battery clip was routed to the battery compartment. The ammeter shunt was then installed with 1 screw to the inside of the front cover. 3 screws were installed in order to hold the printed circuit board in place. Then the wiper assembly was installed and held in place with a nut. The back cover was then installed. 3 screws hold it in place. This was a great time to install the required 9-volt and C battery. I also installed the fuse and spare. The battery cover was then installed and held in place with the captive screw. My Radio Shack Micronta 21 range Volt-Ohm-Meter was ready to be tested. Test lead repair. The test leads banana plugs that came with this meter were clearly bent. I replaced the red test leads banana plug with one I had in my junk drawer. This is the completed red test lead banana plug. The same treatment was given to the black test lead as well. Here is a picture of the replaced banana plugs. One is clearly bent while the other is only slightly bent. The red test probe wire had broken as well. I decided to replace both test probes with better ones I had in my junk drawer. First, I soldered the red wire to the red test probe, then the black test probe as well. Here was the finished product. Testing. I decided to test this meter's functions, including AC and DC voltage, resistance, and DC current setting. Testing the continuity buzzer and zeroing the meter on all resistance settings. Testing DC voltage settings with a 1.5 volt battery. Testing DC voltage settings with a 9-volt battery. Testing the 300 volt AC voltage setting with 120 volts alternating line current. Testing Testing the R times 1 resistance range setting with a 100 ohm resistor. Testing the R times 10 resistance range setting with a 1K resistor. Testing the R times 1K resistance range setting with a 10K resistor. Testing the R times 10K resistance range setting with a 100K resistor. Testing the 30 milliamp current range setting with a 1.5 volt battery and 200 ohm resistor, which yields about 7.5 milliamps. Cleaning. I used my go-to cleaner, Windex, to detail both the front and back of my Radio Shack Micronta 21 range Volt-Ohm-Meter. I removed the back cover again so that I could clean the contact surface. The front and back of this meter were also treated to a coat of Armor All to restore the luster of its plastic case. Conclusion. My newly restored 1983 Radio Shack Micronta 21 range Volt-Ohm-Meter looks right at home on my workbench. I was a little disappointed that I was unable to fix the meter movement and had to replace it instead. This meter is ready to assist me in all my electronic troubleshooting endeavors. Please like this post and subscribe to Radio Boat Anchor so that you're alerted to my future posts. Thank you.